So this is our last chapter for year 12, continuous probability distributions. So the first exercise is about probability density functions. And I just wanted to do a quick video to explain what those actually are. So in order to do that, let's start by taking a look back at discrete data. We're going to be doing continuous data in this chapter. So things like heights and weights, as opposed to individual separate values like the number of people or something like that. So here's a relative frequency graph. So remember, relative frequency is the same as probability. So here the probability of getting a 1 is 1/10. The probability of a 2 is 3/20. This might be a weighted die, for example, because there are 6 numbers. Who knows? It might be a 20-sided die with different numbers from 1 to 6, and one of the faces has a 6 on it. 3 of the faces have 5. 3/10 is the same as 6/20, so 6 of the faces have a 4 on it, like that. And this is the probability then of it landing on each number. Now, what you notice is if you add up all of these probabilities, of course, that equals 1. That equals 100% of the possibilities. Okay, so that will always equal 1. You add up the columns of probabilities, you always get 1. That's really important. And you're going to see that's really important with continuous data. So if I'm asked to find, for example, the probability that x equals 2, well, that's 3/20. We can read that straight off the graph. If I'm asked the probability that x is less than or equal to 2, that's going to be this 1 on 10 plus that 3/20. And if we add those, that makes a quarter. So there's a quarter chance that it's less than or equal to 2. The probability it's between 2 and 5 is all of those 4 added together. So 3 on 20 plus a quarter plus 3 on 10 plus 3 on 20. But actually that's not even how I would do that, because they all add to 1. It'd be much easier to do 1 minus 1/10 and 1/20 together. You subtract these two from 1 and you've got what remains there. And the answer to that is 17/20. So that's how probability works with discrete data. Let's have a look at continuous data. Now, for continuous data, you can't actually draw one of these graphs. So if we're measuring the heights, for example, of some people or something like that, or in this case, the weight of something, you can't draw a column for a single thing. So for example, if you're measuring, say it was the weights of people, so obviously this is not people on that scale, but if you're measuring the weight of a person, the probability that a person is exactly 80 kilograms, that's actually impossible. It's completely impossible. If you've got an incredibly accurate measuring tool, right, incredibly accurate scales, you're going to find a few decimal places here and there away from 80 kilograms. The chance that they actually weigh 80 is actually 0. At some point they will go through 80, but that's only for the tiniest fraction of a time. The width of the column, if I was to do a histogram, would be 0. So 0 times 80, just equals 0. So the chance in this case that the probability equals exactly 3, that equals 0. With continuous data, the probability that's equal, is just 0. We can talk about that more if you in our Zoom chat if you need to. So that means the probability that x is less than 3 is equal to the probability that x is less than or equal to 3. So whether it's less than or equal to doesn't matter. In this particular graph, I would estimate it's approximately just under 50% of the curve. So let's just say it's approximately half. This curve, this is a probability density function. And the way the function is defined is that the total area of the curve equals 1, just like all of these added together equaled 1. So this area is equal to 1. So from, or 100% you might think of it. So there's 50%. As a decimal, that equals half. Okay, so the total area equals 1. So I've said y equals f of x is the curve, which is equal to the probability of x. That's how it's defined. So the integral from, notice how they don't quite touch here. because it might go on for ever and ever. I mean, obviously the weight of something's not going to be less than 0, but we think of it as going on forever. It never touches. So that probability, that total area, equals 1. Okay, so the probability that a value is between 2 and 5, if I go from 2 to 5, that probability is the shaded area. Okay, that is how this curve is defined to be. It is defined that way, that this area will give you 2 to 5. If you want it from 2 to 2.1, it's that little area there. If you knew the probability of it being less than 2, you could find the next point on the curve if you knew the probability of it being between 2 and the next point on the curve. Okay, so the shaded area gives you the probability. So that means it's the integral from 2 to 5 of that curve with respect to x. So you can really see the importance of our calculus here that we've been learning.